Saram Triply YouTube channel. Let us discuss Module 3 Computational Tools Continuation Distribution System Automation Requirement of Power Grid, right? So, distribution system in the sense like power system automation in the sense like if suppose number of power plants will be there, a number of power plants integrated into main grid. So there is automation is required. I mean like switching the power supply from one generating station to the another generating station. Suppose for example, I'll tell you distributed generation. Okay, like integration of distributed generation. So for example, in our college we have solar power plant. Solar power plant is integrated with the main grid, right? So that storing and then like automation, everything included in the distributed system automation required in the power grid. Distribution automation and control involves delivery of energy to the consumer. So it involves delivery of energy into the consumers. How the power supply is delivered, and then how it is distributed, and then how the proper calculation done, and then how much consumption is needed, how much demand is required. That will be included here. So as you can see the diagram, there is a distributed automation for distributed system. So as you can see here, uh, there is a several like parameters this DS automation distributed system depends. One is like power quality. So quality of the power like voltage quality, current quality, or voltage harmonics, control security systems. They're just like a distributed control system. Like if suppose whatever generating voltage is must be matching the main grid or not. That also quality of the power, and then voltage control power quality. So next there is a trouble call. So analysis of crew dispatch. Suppose there is a anything happens in the power systems or components or power system analysis. So that also monitored, and that also like a two-way communication. Next network reconfiguration. If suppose um, network reconfiguration done because of minimum losses and load balancing switching, right? So if suppose minimum loss occurs, definitely efficiency increases. If suppose load balancing occurs and then load variations will be there, that managing occurs, definitely it's fine distributed generation. Next system restoration. So minimum losses, voltage optimization switching, so two-way communication will be there. And next there's a demand side management analysis, optimize the units and energy usage. So demand side management in sense managing the customer point of view and customer side. So suppose if suppose the one customer needs more number of power supply and other customers needs less, and then so if suppose customer needs more power at a particular time, to achieve that demand, we have a distributed generation systems system, and a stop fault and diagnosis. So even though distributed generation, if suppose fault occurs or abnormal condition occurs, automatically it will be diagnosed and self heal, right? Self healing will be occurring in this overall system, right? So this is the concept. And let's see, next there is a end user appliances level of the smart grid. So in the end user level, we have see, as you can see the diagram before one, there is a end user in the sense like customer side, right? See here, there is a customer switching and like network configuration, I mean demand side management analysis. So optimizing the unit energy usage. So just like a end user side, right? So it's a what is the end user in the power system components? End user is customers, right? I mean consumption, power supply consumption. So distributed generation or end user side, that everything must be automated, and then we must satisfy the power, I mean like power system consumers, right? Just appliances level of this market. So appliances level in the sense, as here we have to use energy efficient appliances. Suppose if you're using a incandescent lamp or something like more consumption, power consumption devices, so what happens? So consumption also increases, and also unit consumption increases, and then we have to pay more amount, right? So appliances level automatic automation, home automation, PLC based automation, SCADA automation, so that must be implemented in the power supply system. So because smart grid, right, smart grid cannot be achieved by only generation side and then transmission side. It must be included generation, transmission, distribution, utilization, right? So everywhere we have to make a smart grid, like automatic power supply system, then only it looks like a smart one, right? Applications of our adaptive control and optimization. So optimizing the power supply losses and the power supply components, power supply usage, definitely the adaptive control, so it must be adapted in the power system components. So these are the concepts we discussed in the third module, right? So next we'll look into uh, second, the fourth module, right? So just to consider.